Thanks, everyone. I don't know if you noticed on the previous slide, my title is different. That's because at Oracle, you change titles really quickly. So anyway, the last talk for today, the talk is called Path to Resilient and Observable Microservices. Just quickly about me. Right now, I'm a consulting solution architect at Oracle. I worked at a team called the A-Team, just like that old TV series and a movie. Previously, I worked on a serverless framework called the FN project. But what I've been working mostly with is Kubernetes, service meshes, Docker, Golang, JavaScript. I pretty much worked on a lot of stuff, and a lot of things that you would say are buzzword things. So if there's a buzzword, I probably worked on it. I also wrote a couple of books. There are a couple of old ones about Office and SharePoint, and I wrote a book on Istio and Cloud Native, all buzzwords again. So what I'm going to talk about today is not necessarily microservices. You probably heard about microservices today a lot. At least I'm not going to talk about this directly. Anyone in the room already implementing microservices or? Oh, wow, all right. That's good. So I'm not going to spend too much time on the theory. I'm just going to show you some things you should keep in mind while you're implementing your microservices, and some tools and techniques that you can use to make them more resilient. And I'm going to show you how you can test your services for resiliency. So the first thing that you're going to notice when you start moving or breaking down your monolithic application to microservices, there's going to be way more things to manage that you had to manage before. Previously, you probably had like one monolith, one code base. Now all of a sudden, you have multiple code bases, you have multiple deployments, and there's all these different components that need to work together. In addition, you're probably not just running a single instance of this component, you're running multiple instances. So putting all these things together, it can make stuff very complicated and complex. So there are a couple of things, actually there's a bunch of things you need to figure out. One of them being, how do you take all these different instances that you've broken your monolith into, how do you go and deploy them to all those computers and all those machines that you have lying somewhere? Do SSH into them and do it manually? Probably not, right? You're probably going to go with some orchestration tool to do that, like Kubernetes, and you're going to package your apps together in Docker images to solve this problem, right? However, those tools are not going to solve all your problems magically, right? Kubernetes will make sure, for example, that your services are evenly distributed across your cluster, across all the VMs. It's even going to restart your containers when they fail. There's health checks, there are readiness checks. But there's still a lot of things that can go wrong, and you can even say that once you move to microservices, you might even have more problems than you had before. So what do you need to do, right? This is where the service resiliency comes in, and this is what I'll talk about today. What you really need to do is you need to achieve this resiliency state and make sure that your services are resilient and observable so you actually know when something goes wrong, right? So what is resiliency? It doesn't have to do anything about avoiding failures, right? Failures are going to happen. It's more about responding to failures in such a way that there's no downtime or data loss. Based on that, we could say a very simple goal of resiliency would be to return your service to a fully functioning state after a failure occurs, right? There are two aspects to the service resiliency. First one is high availability, and this one basically says that first, your service is running healthy and it's in a healthy state. Second, there's no significant downtime. This is where those 99 and .9 numbers after that come in. Your service is responsible, so users and or other services can interact with it. And finally, services are meeting your SLAs, right? The second aspect is disaster recovery. And this is all about how to recover from very rare, hopefully rare, but major incidents, right? And this involves data backupping and archiving and stuff like that. You can also say that disaster recovery starts when your high availability design cannot handle the impact of failures anymore. This is pretty much when stuff goes like really, really wrong. So how do you get to that state where you can say, well, my services are really resilient? So there's a couple of things that you have to keep in mind. First one is you really have to understand what your requirements are, right? How much downtime can you handle? Is it 3 nines, 4 nines, 5, 7, 10, whatever? It's up to you to determine that, to understand your requirements. And based on that, you also keep in mind that more downtime you have, you're probably breaking SLAs and SLOs, which is making your customers really unhappy, and you're probably losing money. Next one is to define the service availability. So what does it mean for service to be available, right? Is it that the website is up and running, or does it actually have to do something beyond that? Again, it sounds very simple, but it's something that you should be thinking about as you're trying to make your stuff more resilient, right? Next one is make sure you review your design and identify all the failure points in your system architecture, right? And come up with the things that can go wrong and how they can go wrong. Once you have that, once you identify those failure points, you need to figure out how are you going to detect the failures and how are you going to recover from those failures in case they occur, and they probably will occur at some point. So ask yourself questions such as, how will the service detect this failure? How will I respond to it? And how am I going to log and monitor for this failure as well? For example, if service is unavailable, we will return a 500 status code or whatever. If caller is not authenticated, we will return a 401, etc. The next 2 points are, even though they're at the bottom, they're probably extremely important. You need a way to test your services as well, right? So you need a way to be able to simulate all these different failure conditions, right? Basically to be able to detect and recover from them. Like, you need to test for that. Finally, monitoring, extremely important as well, right? Because in order for you to know what are you doing and what's happening, you need a way to monitor for all these things. Next, I'm going to talk about some strategies and just go through them quickly. And I can help you with the service resiliency. So the first one is load balancing, and this is basically saying that any service that you have should be able to scale out by just adding more instances to it. And there's different load balancing algorithms that go between all those instances. And this will help you. This is one way to help you to achieve better resiliency, right? Next strategy on the list is timeouts and retries. And this is a crucial strategy for making your services available, because network can introduce a lot of unpredictable behavior, and one of them is latency, right? So how long do you wait for some services to respond, right? You can't wait. I mean, you can wait for 3 hours if you want, right? But you probably shouldn't do that. You need to have some timeouts in place that says, if something goes wrong, or if I'm waiting more than 5 seconds for a response, let me just time out instead of waiting more, right? In addition to the timeouts, there's also retries, right? So as network is very finicky, it could also be experiencing some transient failures, meaning if you only retry 1 more time or 2 more times or 3 more times, the call might have succeeded. Be careful with retries, because some of the calls should not be ever retried. For example, if you're trying to authenticate a user and you get a response back from a service that the password is wrong, there's probably no point of retrying that. The password is still going to be wrong, right? However, if it's something different, if the error is something that could be retried, feel free to go ahead and retry it. Next one is circuit breakers. How many of you heard of circuit breakers? Okay, so circuit breaker is a way where you can secure or protect a certain portion of your service or the service itself from making unnecessary calls. Like, for example, if I do all my timeouts, all my retries, and service is still failing, it doesn't make sense to keep on retrying, right? Because I know it'll probably fail. So what you can do with a circuit breaker, you can say, well, if I get 5 consecutive errors from this service, I'm just gonna take it out of the load balancing pool, right? So next time someone else called the service, we will return the error right away. So you're not putting any unnecessary strain on your system. Data replication, this is just a general strategy for handling any non-transient failures in the data store, and then many storage technologies have this replication already built in. Graceful degradation, this one is just saying that even though your services might be experiencing errors or not necessarily working correctly, or there's an error or whatever, you could still potentially offer your users a good experience, right? Instead of providing them 100% the best experience ever, maybe you can gracefully degrade the functionality and provide them only 80%, right? Note that this is probably not valid for any critical applications, right? Especially if you're on an airplane or something like that, right? I don't want any graceful degradation. And finally, rate limiting. Make sure you're rate limiting any requests that, especially if you're doing like public APIs, because you don't want a single user to flood you with requests and then bring down your whole system and by creating excessive loads. So this is all nice theory. So how do you actually implement this in the real world? So I'll talk about the approach with the service mesh. And I know there's multiple different ways that people have done this. People are doing this different ways. Service mesh is just the one way you could do this. It's not the best tool ever for this. It's just one way. Keep that in mind. So enter service mesh. This is another buzzwordy thing this year and the past year. I'll just briefly explain what it is. The definition says that this is a dedicated infrastructure layer for managing service-to-service communication to make it more manageable, visible, and controlled. So it's pretty much all about the communication between your services. So on the left side here, I have like a simple diagram with 3 services, and the services are happily talking directly to each other, right? On the right side, same 3 services. However, in this diagram, I've actually installed or applied a service mesh. So what service mesh does, it installs or injects a proxy next to every instance of your service. So any communication, so any requests coming into your service or going out of your service will be intercepted by that proxy, right? And the proxies are then controlled by a control plane that defines them, reconfigures them. Like you can create different set of rules, and those rules get translated to the proxy configurations, and then you can do stuff like circuit breakers, you can do retries, you can do timeouts, you can do traffic routing. You can do a bunch of stuff with this, right? I'll specifically talk about Istio Service Mesh, and Istio Service Mesh uses this sidecar proxy model of deployment. There's a different proxy model of deployment as well, where you have a single instance of a proxy per each node, right? If you have like a cluster of 10 nodes, you would have one instance of the proxy on each node, and then services would talk through that proxy, right? And this is at a very high level and very quickly how this works. And a great benefit of a service mesh is that certain functionality and network-related logic that you previously had in your services, like retries and timeouts, can be pushed out of the code and have it on the mesh level, right? So you can quickly go and change all the settings for all of your services at once. If I go back to this list, the things in bold are the things that service mesh can help us with. So this is load balancing, timeouts and retries, circuit breakers, and rate limiting. There's also a bunch of other things that Service Mesh can help you with, such as traffic management and security, but those are out of the scope for this talk. All right, so let's talk about briefly how do you test for service resiliency. As you can imagine, this is not the same as doing like unit tests or functionality tests, right? Because you're pretty much testing how your services would behave, or not even just services, the whole system would behave under these failure conditions. So at a very high level, there's 3 steps here. You're going to conduct the test. You're going to measure the results of your tests. You're going to analyze and fix the issues. Anyone knows what the 4th step is? No? It's basically the first step again, because you're never going to finish testing. You're always testing forever. I've heard there's people still testing code today. So, all right. So, what can Service Mesh help you with here? So, Service Mesh has 2 features related to testing for resiliency, and it's basically the ability to inject delays and inject faults into your services. For example, for the delays, you could say, whenever someone calls this service, I want to wait for 6 seconds before I return a response, right? So you can simulate network latency, or you can actually simulate your service being slow. Similarly, you could say, for 40% of the calls that are being made to this service B, or whatever I call it, I want to return a 404. Or I want to return a 503, or whatever you want, right? Basically, you can simulate all these things without changing any code, pretty much. You're basically changing just the rules that are being pushed to all the proxies. Just briefly about observability. What is observability? So this is the act of measuring, collecting, and analyzing metrics, traces, logs, events, and all other signals from your services. It is crucial, as I mentioned, for resiliency, because you need to know when something goes wrong, and when it does, you need to have enough information to figure out what and why something went wrong. Basically, to have enough data that would allow you to go and investigate stuff. If you think about the observability as a pipeline, there's multiple parts to it. Like you have to instrument your services. You have to make sure that your services are actually emitting valuable data. You need to collect those metrics, ideally in a centralized place. Once you have them collected and maybe consolidated, you can go on to analyze it, and then finally, you can use things like Grafana to create graphs or PagerDuty alerts based on that data that you gather from your services. So here are some of the good practices, best practices, however you want to call them. This is definitely not any exhaustive list. This is just a couple of picks. First one is to make sure that your services are actually using correlation IDs, right? So if you imagine Amazon or any website front end, whatever, you go to a website, and based on your actions on the website, some of the backend services are getting called and invoked. So how do you trace, if your service 5 levels deep fails, how do you know what caused that failure, right? So if you create a correlation ID or some unique GUID or whatever you want to call it, whenever a request starts, and then you pass that same correlation ID through all the calls, it makes it much easier to trace the complete calls throughout your system and see what's going wrong. Make sure your logging is structured. Like I always say, it's better to have logs that are machine readable versus human readable, because if it's easier to read it by a machine, then you can always parse it and make it easier to read it for the humans. But if you do it the other way around, you're going to have a harder time parsing a human readable log entry than a computer readable one. Of course, don't log any private information, right? I think this is common knowledge. No passwords, credit card numbers, whatever have you. Don't do that. Even if you're thinking you should, don't do it. Like there's ways that you could obfuscate that information, but I would rather not log it at all, so you don't have to worry about it. Also, for logging, make sure that you're using a common logging format in all of your services. And this is especially important for time zones, right? Like you want to use the same time format in all of your services when you're logging, because if you don't, it's going to be a mess. It's going to be easy when you have 1 or 2 services, but if you get to like 10, 20, 50, 100, whatever, imagine how hard it is to parse anything if the time zones are different. Finally, unique metric names, just so it's easier to distinguish. You can categorize your logs as well. This is just a small selection of things that you can think about and do for observability. All right, so once you have all these things collected, all these metrics and signals, you need a way to represent and visualize the data. And this is where Grafana comes into play. Anyone used Grafana? Oh, yeah, perfect. So yeah, Grafana is a tool. It has a bunch of nice graphs. It's backed by a bunch of data sources, like you can use Prometheus. In my example, I'll use STO with Prometheus. And you can create nice-looking charts and stuff. Next one is Jaeger. So this one is for distributed tracing. So all that correlation IDs that I mentioned, Jaeger does that for you. It can stitch the calls together. And then it allows you to go and actually see all your calls throughout the system. Kiali is another thing that gets installed with the STO service mesh, and I think it's called as a visualization for your service mesh, and it looks really nice. It's very visual. You can see how your services are connected to each other. You can see what the requests are being made between them, etc. The first 3 are the service mesh specific. Of course, you can use them anywhere else as well, but those are the things that get installed with STO service mesh. And at the bottom, I have the Elasticsearch and Fluentd and Kibana stack. That's basically for logging, pretty much. And finally, PagerDuty. Anyone familiar with PagerDuty? All right, how do you like it? Depends on the time. So I hate PagerDuty. I really do, because it's for anyone who doesn't know what it is. So you go to this website, and there's a phone app as well, right? You go there, you enter your email, you enter your phone number, and then someone will call you at 3 in the morning. That's the short story, right? Because you can hook it up to the Prometheus data, you can hook it up to different data stuff, right? And as soon as something goes wrong, right, if there's an alarm, you're gonna get paged, and then you can go in and you can click through everything. Don't get me wrong, it's an awesome tool, it's just awful, right? Like no one wants to be waking up at 3 in the morning. All right, so I'm gonna show you a quick demo. So this is my architectural diagram, whatever you want to call it. So I have 3 services that I'll be running in a Kubernetes cluster on OCI. I have a weather service, city service, temperature service, and I also have a serverless function running that's called the wind function. And the idea here is that I'm going to make a call to my weather service that's exposed publicly, and I'm going to pass in a zip code or postal code. And that weather service is going to make a call to the city service to get the city and state name, and it's going to return me the temperature based on the zip code. It's going to call the wind function to return me the wind information. All the data that's being returned is fake, of course, but the whole system is not fake. It's all real, so cross your fingers, and let's hope that this actually works. It's going to work. Otherwise, I have 20 minutes to, I don't know, tell you jokes or sing or something. All right. How is it more? People in the back. Good, bad, good? Okay, perfect. So I'm going to do, how many of you familiar with Kubernetes? Okay, perfect. So I have a cluster running live in a US data center in a galaxy far, far, oh, there it is. So I have a cluster with 6 nodes running. So it's a real cluster. I also need to open this, which is my cheat sheet. And I think I have these 3 things deployed already, but I just to be sure, okay, I already had them deployed. I made a mistake. All right. All right, so let's see, kubectl get pod, so I'm just gonna make sure that the stuff is up and running. And I have a single instance of each of these services running. As soon as it comes up, you will see. But you'll also notice that it says 2 out of 2. So that second number, the 2, is the proxy that got injected by the service mesh. So the first one is my actual service, and the second one is the proxy that's gonna go and intercept any traffic and all traffic that's passing through these services. So I do have the gateway deployed. So gateway is one of the Istio resources that's gonna allow me to publicly expose my service. Yeah, I had it deployed. It's gonna allow me to publicly expose my service through like service running inside the Kubernetes cluster to the public. There you go. It's a long day. So what I'm going to do is, I'm just going to make sure that, okay, I don't know the IP address. Oh, actually, it's here. There you go. So I'm going to copy this. So it's going to make one request here. It might take a little while because the function takes a little while to wake up. So it's in a deep sleep and everything, so. Or maybe someone is getting paged with the pager duty right now because it's taking too long. I hope that's not the case, but it worked 2 hours ago, so. Let's see. Oh, there we go, perfect. So next time I call it, it's gonna be way faster, so let's try it. Let's make sure, oops, oh, there, no, wrong one. Actually, you know what? Let's just start making a bunch of requests to it, and there we go. There you go. So I'm just making a bunch of requests to the service. And let's do this, and let me show you Kiali. And let me show you Grafana. Let me show you Jaeger. All right. Let me just go here. Trying to see, oh, there it is. That's what I've been looking for. I think I had it applied, so it was taking a long time. There you go. Oh, this is fine because it'll come back. There you go. You thought it's not going to work, right? You really wanted me to sing and tell jokes. You don't want that, especially not singing. All right, so let me load this. So the requests are jumping here. It's going fairly fast, I guess. So let's look at the Kiali. This is the service mesh observability thing, or tool. There you go. Oh, I forgot the most important feature here, which is traffic animation. There you go. This looks really cool, right? So you can see I have my weather service. The weather service is calling the city service. It's also calling the temperature service. And it's also calling this nice and long URL, which is my function. And the ingress gateway is just my entry to the cluster. This is what's exposed publicly. So this is all nice here. Grafana. Since a lot of you mentioned you're familiar with this, I'll just quickly show a couple of graphs. So as you can see, you get this typical requests and all the request duration, the client server request duration, success rate, a number of operations. And all these nice graphs were just created automatically. I'm not a big Grafana person, so I don't really know how to create really nice Grafana dashboards, but luckily these were created for me. And as you can see, it automatically recognizes all the services as well. And then it shows you all the calls that are being made, how long the calls took, etc. And all this information, these metrics and everything, those are gathered by those proxies. Remember those proxies sitting in front of services? Those are gathering those metrics and sending them to the Istio's control plane, a component that runs in that control plane. All right, so let's go and inject a 404. So I have a, let me zoom in. Everything in Istio is YAML, just like everything in Kubernetes pretty much. So what I'm doing here with this piece of YAML is I'm creating a resource called virtual service for my city service, Kubernetes service. There's too many services there. And I'm creating a single route and single destination. This is the actual address of my Kubernetes service. And I'm saying I want to inject an abort for 60% of the time. And I want you to return a 404. So if I get all this, if I'm able to copy paste. Oops, there we go. Let's go up here. So you're going to notice as soon as that thing is applied, you'll notice at the bottom that the responses will be different. There you go, so this was configured. There you go. So you can already see that, if I catch one, you see the message there that says, service returned a non-200 code, it was 404, and it was fault filter abort. So this is the filter that's coming from that proxy, and it's basically saying, no, you're not getting anywhere, it's 404, right? And it's only for the 60% of the time, right? So the Envoy and everything is smart enough to do that complex math to figure out when is it 60% on or when is it 40%. Now if I go back to Kiali here, you'll notice that this turned orange. So if we click here, you'll see that there's 400s there. I know it's small, sorry. Apologize to people in the back. But this is, right now it's showing 94, 200, and then 4x has 5.97%. But if we wait long enough, this will be 60-40. Again, it's the math thing here. There you go. So it's getting closer to that point now. But this is like a very, very quick way where you could go and visualize and actually see what's going on with all of your services. And then, of course, as you probably imagined, there's going to be something here as well that's going to show that this is failing down here. So you'll see the number of 404 operations went up, and the 200s went down, 60-40 again. And then in Jaeger, I just remember I forgot to show you this. So Jaeger is a distributed tracing tool. And in here, I can pick my weather service, and I can get all the traces. For example, this is one here. And this one will show you, again, how the calls were being made to your services. I know I only have 3. If you had 10 or 15 or more, it would be probably more useful. And another thing that I want to mention here is these are all the calls that are made, like these traces are collected at the edge. So from service to service, not necessarily inside of your service. But there's libraries for, there's open tracing libraries for pretty much all the popular programming languages. And that would allow you, if you use that library, you can create your own spans and traces from within your code, right? So if you had some critical sections in your code or whatever you wanted to trace, you could create it there, and then you can drill even deeper. Let me also show you the status code equals 404. Let's do this one. So this is how a 404 would look like here. So it's going to return me a status code of 404, and then the response flags are set to FI, which means that it was a fault injection, right? So you can see it here as well. And then the nice thing is it actually also shows you how long your requests were taking. So let me reset this back. Oop, there we go. I need a better way to select these things. And if someone's going to mention to use Vim or Vi, I'm not going to use that. Because I don't know how to exit it. That's the same joke I made yesterday. If you were at the workshop, I apologize. So now that I reset this back, you'll see that the requests are back the way they were. There's no errors anymore. Similarly here, If I refresh, and if I would wait long enough, this would turn green again, and everything would be healthy and happy. Same thing here. If I refresh, you already see that the 404s dropped, and the 200s are going up. All right, let me go here. All right, the next thing that I'm going to show you is how you can inject a delay into your service. So what I'm going to do is, this is the same, I'm going to inject it into temperature service, but it works exactly the same if I would inject it in any other service. So what I'm saying with this is I'm going to inject a delay for 100% of my requests, and I'm going to make them last for 6 seconds, right? If I do this, okay, there's a lot of text here. And you'll see, there you go. So you'll see how that this will start becoming slower and slower. There you go. Come on, there you go. And now if someone counts, it should be about 6 seconds. But instead of looking to this, we can go here again. And said that it was a temperature service. Let's go back, let's refresh. And then we should see it here. It should drop soon. Come on. Not there yet. Not there yet. But yeah, basically the change should be reflected here. Oh, there you go. See how it jumped from like milliseconds up to more than 6 seconds there. B99 is almost 10 seconds. And then same thing here. And we're going to still use the weather service. I'm going to remove this, and I will say, show me everything that has a minimum duration of 6 seconds. And this is also a nice tool if you want to figure out where your slow spots are in your code, right? If you instrument the code, and if you add all these traces in and spans, it's easy to say, well, let me see if there's anything that's slower than 2 seconds, or anything that lasts at least 2 seconds, or whatever your number is, your magic number. So this one was 6.4 seconds, right? And you'll see that it shows me the actual duration here. And then this one is going to show me, well, I think it's probably messed up a little bit, but yeah. I think we'll see it here. Or of course, maybe not, because demo was doing so perfectly, but anyway. You see the 6 seconds here, so please trust me that it works. It was slow, and then this one is showing that it's slow as well. All good here, all green. Let me go back. So the next thing that I'll show, and I have 6 minutes, so I'll go really, really quickly. So what I'm going to do is I'm going to inject a 2-second delay, like a hard-coded delay, into my temperature service. I'm going to quickly... These are things that are very hard to demo usually. Like I always wanted to demo circuit breakers, but it's just so hard to demo everything. Okay, so I injected a hard-coded 2-second sleep into the temperature service, and what I'm going to do is I'll set a timeout to 2 seconds, meaning that the call will time out, right, because it's going to take more than 2 seconds. But then I'm also going to do 3 retries. And I'm going to retry on 404, 429, and I'm going to have a half a second delay, or half a second timeout per each retry. So let's see if this, fingers crossed, hopefully we'll see it somehow. There you go. So this should start failing soon, I hope. Or maybe it won't. Anyone knows what an HTTP status code is for a gateway timeout? 502? Let's see. If the demo doesn't work, it's your fault. Yeah, this might have been the problem because I was only retrying on these two, so let's see. It's taking a bit longer, right? Yes, no, maybe. I don't know. Let's go back to Grafana and see. This was temperature service. We should be seeing something here, but if we don't, no. No, it's odd. It's still 200. Let's do whatever. I really wanted to end this talk on a high note, but it was 504? Well, let's see how many we can do. But if nothing else, you can share the blame with the other person who said 502. No, I'm just kidding. But anyway, so the point here is, right, the point that I want to make is this is very flexible, right? And all these, the timeouts that I didn't show and retries that I didn't show can be combined with delays and with those status codes, right? So you can combine all these things together. It doesn't have to be just one thing, right? You can combine everything together, and then you can really get into a state where you can stress and test your services as hard as you want and as hard as you like to make sure that they're truly more resilient than they were before. Let's go back here. I have 3 minutes. And just a couple of things where you can get started. Kubernetes IO for all your Kubernetes needs. I mentioned OKE functions on Oracle Cloud. Feel free to use it anywhere else, but it's the same Kubernetes, managed Kubernetes that's on all the clouds. Istio IO, if you want to use this exact same thing that I did, they also have very good documentation. Also, there's other service meshes that you can try, and they have they have parity with with the same features, right? So you can get the same features with other stuff. Thank you very much. Follow me on Twitter. Thank you.
Peter, we have a couple of questions. Are you ready?
I don't know if I'm ready, but I can't say no.
Okay, we'll see about that. Okay, there's a tough one. ELK or a gray log?
That's a good one. I don't know. What does the audience think?
Raise your hand for ELK.
2, 3.
Okay, and now for gray log.
Oh, there you go. There's your answer.
So there's your answer.
Right? I figured, yeah. That was a trick question.
It is. I assume. I don't know. I'm just mortal. Don't look at me. Peter, there's another one. Take a look.
Oh, now it's showed up.
There's another one. How large performance drop should we expect implementing service mesh?
Yes, so you will probably expect some of there will be a drop in performance, of course. I personally haven't done any testing on it to actually get the numbers. However, there was a person on the internet, there's always a person on the internet, who did a pretty extensive test on, he basically compared service mesh, like Istio service mesh, Linkerd, I don't know if he did console or not, plus stuff without the service mesh, and he posted a bunch of results. Yes, there were slowdowns, of course, when you're using service mesh because stuff is going through like extra hops. But I wouldn't say it was that big or that crazy. So, but check for yourself, of course. There's one more?
There's one more because we have two similar questions. So people want to know what's the difference between Jaeger and Kali.
So Jaeger is distributed tracing tool that's not necessarily service mesh related at all. You don't have to use service mesh to use Jaeger. However, Kali is more of a service mesh type of thing, where it's an observability dashboard for your service mesh and a management tool for your service mesh. So that's the difference. If you're not using service mesh, you can still use Jaeger. Hope that answers the question. I don't know who it was, but
I think it was. No, it wasn't me.
That's fine.
For sure, it wasn't me.
Hope it answered the question.
We have a little gift for you, and there's another one from the crowd. Please make some noise, Peter.
Thank you. Thank you very much.
Thank you.